For years, seed testing was done using phenotypic analysis. That is, we would look at the seed to determine if it was healthy. Phenotypic analyses are still used today, and make no mistake, they're an important part of seed analysis. But genotypic analyses are transforming what seed testing is capable of and what both the seed industry and farmers are capable of doing. That's according to Kim Kenward, Research and Development Manager at 2020 Seed Labs. Welcome to the Insiders Podcast. I'm Mark Zinkowitz. I sat down with Kim to find out a little bit about genotypic analysis and how it differs from other more traditional types of seed tests.
A lot of traditional seed testing, like purity and germination and vigor, are all based on phenotypic analysis.
Phenotypic analysis, that's another way of talking about tests that involve actually looking at the seed and plant. The next frontier is to actually look inside of the seed and its genetic structure.
When you get to the molecular level, when you're applying the genomics capability, that's the point that you're actually starting to be able to break it down to finer levels of analysis.
This technology, of course, has been around for a while, but it's responsible for a lot of the new varieties that are coming out that many of us take for granted.
There's the whole pipeline of new varieties that are coming out, because those are all have a certain component of molecular breeding associated with them. So you're looking at markers that enable you to combine good traits within plants into a single variety that has everything that you want in it. So that's one way that the farmer benefits. The example that I'm particularly obsessed with right now is wheat midge.
Wheat midge. Now, most people in the seed industry and people who are involved in farming know about midge-tolerant wheat. Kim notes that resistant varieties have a gene bred into them called SM1 that makes resistant varieties immune to attacks from the wheat midge by killing any midge that feed on the resistant plants. Now, bags of these midge-tolerant wheat varieties contain a small percentage of non-resistant wheat seeds, a refuge that ensure the midge don't become resistant to the SM1 gene. It's a revolutionary technology made possible through genomics and genotypic analysis.
Because you have a very specific target of how much refuge that you want in there in order to preserve yield in the event of an infestation by the wheat midge. But you don't want resistance coming up in the wheat midge. So you need to have a certain amount of refuge there.
Kim notes that genomic technologies have had a big influence on the seed testing sphere over the years and will continue to do so.
You're just trying to develop good quality seed with the best technology available. The best technology available in our case as a seed testing lab is often driven by the tools that they're using to develop the new varieties. So when she got into molecular breeding or GM, you actually had to bring in molecular technologies in order to detect them. Because the differences are so subtle, you can't do it at a whole seed or whole plant or even a bioassay level in a nice, timely fashion.
Kim says while genomics technologies gained a lot of publicity through GM technology and controversies surrounding it, the future will look quite a bit different now that technologies like gene editing have arrived.
For the short-term future, I think we're looking at a lot of very subtle changes in terms of what we're going to see available to growers. Well, GM itself created a great deal more awareness of the technologies that were being used, and we ended up with a much bigger regulatory environment associated with it and a lot more interest from the consumer side. So it wasn't just farmers making the decisions anymore. It was everybody suddenly has to get in on the act. And I think downstream, that has huge implications in terms of what's going to happen with gene editing. So you can already see them being very cautious about what products they're starting to put through the regulatory process. So a lot of what we're seeing is just duplicating stuff that was sort of pioneered through GM. So we're seeing herbicide resistances being created in the plant based on what mutagenesis was creating before. Then from there, you're going to progress to slightly bigger and bigger changes.
In the realm of seed testing, genomics is allowing people like Kim and the staff at 2020 Seed Labs to do some pretty amazing things. A great example of that, she notes, is a new test for soybean cyst nematode that has been developed by 2020 Seed Labs.
With SCN, there are tests available, and they're actually, you're looking for eggs and cysts, or you're actually pulling the motile nematodes out, and you're actually identifying them by eye, which is a very old-fashioned phenotypic test. You can pull plants, and you can actually see cysts on them if they're infected. But so there isn't necessarily a need for it. Once you've given up and it's your field's infested and there's a limit to what you can do, so you're just trying to contain the damage. That's what the older testing methods were capable of doing. What we're trying to do with the DNA-based testing is we're trying to actually monitor it before you get an invasion and before you start getting those yield losses, so that you can be more proactive in preventing things from happening. So it's one of those differences that seems subtle, but is actually very huge in terms of what's practical on the ground.
Thanks for listening. For more great podcasts, visit germination.ca.